Today we're going to talk about NVMe storage disaggregation, what we consider to be the next horizon. My name is Gary Kotzur. I am Marvell storage CTO. We can say that Ethernet-based storage disaggregation is not new, but there have been some barriers to the adoption of it. So today we're going to talk about another option that will hopefully minimize those barriers. So next slide. So just a little bit of background. Of course, we all know that SAS and SATA are interfaces that have been the incumbent for a long period of time. And then whenever SSDs came along, it was natural for them to adopt those two interfaces. But in 2013, the first NVMe SSD was introduced. And then today, NVMe is now the dominant interface for SSDs. Now, there is a part of the industry that wants to use NVMe for hard drives, and there's a very collective effort in order to do so. So it raises the question of, in the future, are we going to be looking at NVMe as the only storage interface for all our drive needs? Just want to pose that question. So just a real quick, I mean, everybody has seen a server, but just to recap, it's fully integrated in the fully integrated in the standalone implementation where you have both compute, memory, and storage. Storage is composed of SSDs or hard drives, and it could be SAS, SATA, or NVMe. And of course, you have PCIe slots for optional capability. Very similar for the storage array. The difference is now you have two compute controllers for HA capability. So let's talk about storage disaggregation. One thing to note is that server configuration and that storage array configuration can be virtually realized with Ethernet-based storage disaggregation. The other implementations that it can support are SDS as well as virtual SAN. So let's go over the pros and cons of storage disaggregation. It is based upon NVMe over Fabric, and it takes advantage of the ubiquity of Ethernet. It's composable, so as you mentioned before, you can realize many different types of implementations using storage disaggregation based upon Ethernet. It removes the overhead for the server burden. It shares storage down to the drive level, and it simplifies failover for those who are concerned about HA capability. And it also simplifies maintenance, installation, as well as configuration. A couple of cons that are possible with storage disaggregation is that if you compare it to, say, a SAS JBOD, there is probably a cost adder that will be involved with it. Also, depending upon the applications and the profiles that it needs, it could actually cause a performance challenge as well. So just real quick, there are different types of disaggregation. It could be vertical or horizontal scaling. And for vertical, it's where you attach multiple storage arrays to a server, and that's your lowest cost of implementation to scale your capacity. In the case of horizontal, where you just take a share nothing server loaded with storage, and you're using Ethernet to connect them. And this provides consistent performance because as you scale, you keep adding additional platforms, and that increases your capacity and your overall performance. One thing to realize is that with Ethernet-based storage disaggregation, you can realize either of these implementations very easily, just depending upon how you configure it. So if I wanted to implement this Ethernet JBOD, what are my options? Well, I've listed three here. The first one is based upon a server, and the nice thing about it is that I'm just using a standard server loaded with drives, and I load it with storage software. One of the downsides, though, is that I don't have HA capability any longer. And if I look in the case of DPUs, I could have two compute controllers inside of my enclosure, and that provides HA capability along with it. The last one, which is the one that we're proposing here, is that if we have what we call an E drive, which is an Ethernet-based drive, and more specifically, an NVMe over Fabric drive, all we need inside of the two controllers is just an Ethernet switch. And then it looks almost identical from a high level of the topology of a SAS JBOD, but instead of SAS expanders, we have Ethernet switches along with these drives. So whenever I talk about an E drive, there are a couple of ways that you could implement this. You could have a fully integrated E drive, in this case, either SSD, which has a bridge chip, or the functionalities integrated inside of the SSD controller. Or you could have a bridge chip that sits on an interposer. The benefit of the interposer is that I can use any vendor's NVMe SSD behind it. And so that provides the advantage of having multiple sources for your SSDs. So let's look at some of the possible trade-offs. I'm not going to go through each one of these, but I just want to kind of point out some of the key ones, at least in my opinion, is that the server does not have HA capability. And when I compare other aspects such as highest performance or even scalable performance, it doesn't meet the criteria relative to, say, the E drive implementation. And the same thing with the lowest cost and the lowest power. Likewise, if I look at the DPU, it's very similar to this server, except that it does provide HA capability, but whenever I compare the other aspects, the E drive still performs ahead of that. Now, one thing to note is that there is not a standard today for the E drive. Just want to call that out. So let's look at a high level of this platform we call an EBOF, which again is Ethernet-based JBOF. And I'm showing here that we have an E drive that's implemented with the bridge chip on an interposer in front of the NVMe SSD. As I mentioned before, it does have HA capability, and it uses the Ethernet switch inside of the controller itself. And as I mentioned before, we have a bridge chip that's just dual port in this particular case. And then, of course, for the NVMe SSD, it can be vendor agnostic. And another thing that's interesting too is that if you look at the cost deltas between, let's say, dual port and single port SSDs today, there are some significant differences. In this particular case, the bridge chip can take a single port drive and make it into a dual port Ethernet drive. So what about hard drives? Now, hard drives are more cost sensitive than SSDs. So we're looking at a different type of configuration. We use the same bridge chip and we pair it with a SAS IOC, and this allows us to connect up to maybe 16 HDDs behind it. And by taking this pair and replicating it, you can cover all the drives that you have inside of this enclosure. So for those that would prefer to use an NVMe HDD, if you want to be on the cutting edge, you can replace the SAS IOC with a PCI switch and use the same approach to scale the number of drives. Oh, I'm going pretty fast. So as summary, we see that the EBOD and the EBOF, they provide connectivity in the form of NVMe over Fabric, in this case Ethernet, for all drive types, SSDs and hard drives, which it's a benefit for the system to configure, for the system IT administrator, because it allows him to hook up everything via Ethernet. This provides easy installation, reconfiguration, and maintenance. In addition to that, if I care about my performance, as I add my drives, it also provides scalable performance that is linear. NVMe over Fabric leverages the benefit of Ethernet connectivity. Storage disaggregation enables composable storage for all different uses, such as the server, the storage array, STS, and virtual SAN. This provides a path for all storage to be based upon NVMe and NVMe over Fabric. And last, as I mentioned before, this provides enhanced options for HA capability, in this case for failover. I didn't kind of go through it, but basically if I have a composable infrastructure, if one of my servers that is running the same storage software fails, another one can easily take over for the drives that are still there. So this brings me to my last slide on a call to action, is that if there is sufficient industry interest on implementing Ethernet-based, Ethernet-based storage disaggregation, I would welcome people to come join and look at ways that we can form a group in order to standardize this overall effort. So thank you.